So let us begin, cabbages. 3 ways to graph a linear function. What is the first way that I taught you this year? You also knew it from before.
Slope-intercept form?
Before slope-intercept form. To put a linear function on a graph. The very first section of this unit.
Function notation?
No. Never mind. I got you. X and Y intercepts. And how did we do it? We had X comma 0 and 0 comma Y. And we subbed into the function, right? Once we were subbed into the function, then we did some algebra. What was the second way that we talked about? No, you already said it. Slope intercept form. And that was y equaled mx plus b. And how that worked is we went to b on the y-axis and counted slope. And where did we find the slope? That was the m. Yeah? Yeah. Now in grade 9, you also had table of values, right? Which we talked about a little, but we're trying to get away from that. So the third method is, this is the new one. Oh, if you would like me to add that in there, m also equals y2 minus y1 over x2 minus x1, which is actually a really good thing to mention there for what we're about to do. The third thing, and this is the new one, point-slope form, which is also called slope-point form. Just depends on who's saying it. And point-slope form looks like this. Y minus y1 equals m x minus x1. Now, does that notation look fairly familiar to us? Of course it does. It's got an m, just like we're used to. It's got x's and y's, and the whole graph is made up of x's and y's, isn't it? And it's got another x and y, and we already know how to deal with those. Yes?
How come there isn't a y2?
Some people write it with a y2.
Oh, okay.
I was just getting to that. All right? Now, whenever you see x's and y's, you know that those values come from the coordinate plane, yes? So, we're going to write this out in big letters here. y2 minus y1 equals m x2 minus x1. Now, please be careful with what I'm about to say. That means what in math? It means a lot of stuff. Give me some of the things that symbol means. Subtraction. Negative. What else? Minus. What else? What if I wrote this? Negative, -4. No. What does that sign mean to the thing that comes after it? Or better yet, this. Negative x squared plus 3x minus 9.
Everything is negative.
The whole thing doesn't become negative because this is already negative. It's opposite, right? So that symbol means all those things. Subtraction, minus, take away. The opposite, right? In this case, this symbol means opposite. So I'm going to write this out with numbers in it in some places and see if you can figure it out. Y minus 4 equals 2/3 x plus 2. Now have a look at that. Have a look at this. And I'm going to tell you right now, some of you already know this answer, so please let the people that don't know this answer think about it a little. I am telling you right now that this form, we could graph it right now without a table of values. One of these others, for example, slope-intercept form, I can graph just by looking at the equation, yes? Right? I go to the B and I graph, correct? Now, look at this and tell me if you can guess how I could graph this. What are some hints from this that might allow me to graph it without actually thinking about it? Ariana. The fraction is where m is, so that's a slope. So if I have a starting point, can I graph it? Yes, because where would I go? I would go up 2 and right 3. Or down 2 and left 3. Everybody agree? If I had a starting point, I could graph this. So now that I know I have a slope, because we're intelligent young people, all I got to do is figure out if I can find the starting point. So, Ariana, what do you think is the starting point? 2 and 2 and negative 4. Everyone agree? Is that a decent guess? Everyone's happy with that guess? All right. That 2 is what value? It's an x value, correct? That 4 is what value? Or that negative 4 is what value? A y value. What do you see there? Y. So what could I write there? According to this, what would I write there? Negative 4 minus 4, which would be what? Negative 8. Does everyone agree? Equals 2/3. What am I writing for x? 2 plus 2. Everyone agree? What is 2 plus 2? 4. What is 4 times 2/3? What's 4 times 2? And so it's going to be 8/3. Does negative 8 equal 8/3? No. So this cannot be right. Is everybody with me? Now let's stop and think about it again. We know that this is wrong. Remember what I told you about this. What do those negatives mean? Opposite. So what would be another guess we could have here? Negative 2 and positive 4. Let's check that. What would go there? 4 minus 4, which equals what? 0. 2/3. What would go here? Negative 2 plus 2. What's negative 2 plus 2? Negative 2 plus 2. 0. What's 2/3 times 0? Does 0 equal 0? So, without even me teaching you, your knowledge allowed you to figure this out, didn't it? So, what can we say now about that point and that point? What did they give us? Because there's those 2 points right there, yes? What did they give us? They gave us the starting point, but what did we have to remember, Hannah? But its opposite of what's written. And how did we figure that out? With an experiment, right? Ariana did a decent guess. She saw 2 and -4. We all agreed that was a decent guess. We tried it. It didn't work. Then we said, all right, negative means opposite. That's one of its meanings. So we tried the opposites, and it did work. Is everybody cool? All right. So let's have a look at this. Is this in this new form?
Yeah.
Yes. How would we graph it? The same way we graph slope-intercept. We go to the starting point and we count our slope. But our starting point is not the y-intercept. What is it now in this one? What's our start? Okay, so there is y1 and x1. So what is the actual coordinate we start from?
-2 and +1.
Except we do our x's first. So 1,
-2.
2, and what's our slope?
-2 over 3.
-2 over 3. So to graph it, we've got a starting point, and then we would count our slope from that.
Yeah.
Yeah, it's supposed to be -2. Everybody good? Mm-hmm. And it's almost exactly the same as slope-intercept, except we've got a starting point that isn't the y-intercept. Now, don't write this down, but look closely. Yeah? Bring that over there. Yeah? What is the value of B? It's the y-intercept, yes? What are its coordinates? What are the coordinates of every y-intercept? 0, y, correct?
Yeah.
So when that positive B moves over there, it becomes negative, yeah? Y is the B. Y minus y equals mx. What's the x value?
X0.
Minus 0. Does that look like point slope form? Do you see how they are exactly the same thing? Everybody? Because remember, this b is 0y. So y minus y, when I move that positive b over here, and x minus 0, x1. The point we would start at would be 0 on the x-axis and positive b on the y-axis. Everybody cool? All right, back to where we were. You tell me the next one. What is my starting point?
-3 and +4.
-3, 4, and my slope?
-1 over 4.
So let's actually draw it. Where would I go first with my slope? Up or down?
You go down.
You could go down how far? 1, and then if I go down 1, then what direction must I go? Down and left would be a positive slope.
Go right.
Down 1 and right 4. What if I went up 1? Then I would go left 4. Does everybody understand? So I could go down 1 and right 4 or up 1 and left 4. As long as the two directions are opposite, you're going to get a negative slope. What about 3? 3 looks different. Look carefully.
-2 and
What is my starting point?
-2 and
-2, -1. Okay, and what's my slope?
You have 1.
Yes, you do.
Y.
No. Say it loud, Tiffany. 1 over 1. Why? Where does M live?
Beside you.
Right there, correct?
Yeah.
What does M do to that bracket?
Multiplies.
Multiplies it. Is there a number in front of that x?
No.
What's the number that we don't write when we're multiplying? 1. So if this was 1x plus 2, 1 times x is x, 1 times 2 is 2. Everybody with me?
1x.
So the slope is 1, so how would I work it? Is it positive or negative? Positive, so where would I go? Up 1 and right 1. Or down 1 and left 1. So they're both negative. Is everybody good? Now please notice, even though it looks different, it has all of the characteristics needed, doesn't it? What about 4? Does 4 look different? 4 looks different, doesn't it? Okay.
Yeah, there's
So
no
what's my
value.
starting point?
There's no value with y.
Negative 4,
And negative
1? What's the number that we don't write?
1.
No, we're not multiplying. 0. Because this would be y plus 0, wouldn't it? Because y plus 0 is what? Y. Everybody good? So what's my slope here?
1 over 2.
1/2. So how do I do it? It's positive 1/2. So what do I do?
Up 1, right.
Up 1,
Right.
right 2, or
Down 1.
down 1, left 2. Everybody good? Okay. What's different in 5?
There's a negative in front of the bracket.
So what's my start?
1. Well, wait.
Negative 5,
Negative 3.
negative 3, and what's my slope?
Negative 1.
Negative 1. So that would be down 1,
Right.
right 1, or
Up.
up 1,
Left.
left 1. And last, this is a nice normal one, just to remind you that they also are perfectly easy. What's our starting point here?
Positive 1 and positive 10.
110, and our slope
4 over 5.
is positive, so
Up 4.
up 4,
Right 5.
right 5, or
Down 4.
down 4, left 5. Is everybody good? It's exactly the same as slope intercept. Still got x's and y's, right? Easy peasy lemon squeezy, yeah? Okay, let's graph it now. We're actually going to graph it. What's our starting point?
Negative 1 and positive 2.
Negative 1, 2. So I go over to here and I put a dot at negative 1, positive 2. Negative 1, positive 2. Everyone agree? Was it better when I really made this big for you guys? When I zoomed it up to 300%? Everyone's okay if I leave it here? Okay, and then what? What's my slope? 2/3. So it is up 2 and right 3. And, because I should do 3 points just to make sure,
1 down 2.
down 2 and
Left.
left 3. Up 1, 2, right 1, 2, 3. Down 1, 2, left 1, 2, 3. 3 points in a nice line. There it is. Easy peasy, right?
Yeah. I feel like this is going to get harder. You're just like,
It's not.
I feel okay.
8, what's my starting point? Negative 5,
And negative 1.
negative 1.
Oh, crap.
Then what? What's my slope? No. 2 over 1. Negative 2 over 1. So it is
Down 2.
down 2 and
Right.
right 1, or
Up 2.
up 2 and left 1. 2, left 1, down 1, 2, right 1. And there's my line. Is everybody good? Now, Ariana said, I feel like this is going to get harder. It's not going to get any harder. You're going to use the same principles, but you're going to have to do more. Read that question. Tell me some key words in that question.
Perpendicular.
Perpendicular. That tells us something, doesn't it?
Y-axis.
Perpendicular tells us something. They cross on the y-axis. That tells us something.
Equation of one line.
And we have an equation. Right? Okay. So what does perpendicular tell us about the two lines?
That there's going to be opposite.
They're going to cross, right? What do we know about perpendicular crossings?
90 degrees.
They hit at a 90-degree angle and something happens to their slopes. What is it?
They opposite
Opposite
of each other.
and reciprocal. So line 1, slope, is opposite reciprocal of line 2. I know that the light went out. It's okay. So that's one thing we know. What's another thing we know? If they cross at the y-axis, that must mean they share a y-intercept, doesn't it? So, that's point 2 that we know. They share a y-intercept. Agreed? And what do we know? What will that tell us? That will give us one of the lines, won't it?
Equation of one line.
Right. But will it give us the equation? Can we graph that just by looking at it the way it is right now? What would we have to do to make this something we could graph just by looking at it?
Subtract 8 out.
I wouldn't move the 8. I wouldn't move the x. Why would you move the y? Because then y would be isolated, wouldn't it? If I do plus y and plus y, don't I have 2x plus 8 equals y? And can't we graph that just by looking at it? Where do I go? Which form is that? Slope-intercept or point-slope? That's slope-intercept. So where do I go?
Go to 8.
I go to 8. 1, 2, 3, 4, 5, 6, 7, 8. And then what's my slope?
2 over 1.
2 over 1. Can I go up 2 and right 1?
Just go down.
I can't, can I? Because what's going to happen?
It'll go off the graph.
I'll go off the graph. So I'm going to go down 2 and left 1. And I should make 3 points, right? I'm going to make a whole bunch just for fun. Everybody cool? Now, what do we know about line 2? Line 2 has to have an opposite reciprocal slope. So what is it? What's line 1's slope?
1 over 2.
Line 1's slope is 2 over 1. So what is line 2's slope?
1 over 2.
Negative 1 over 2. And what else do I know about line 2?
They're the same. Wait,
They share a y-intercept, correct?
Yeah.
So I already know my slope. What's my y-intercept? 8 x, y. Everybody good? Now that was using slope-intercept, right? So it would then be down 1, right 2. Down 1, right 2. And we would have that. And if I got out a protractor, what would I find out about that angle? It was 90 degrees. Now, you may be saying to yourself, Myers, why did we just spend half the class talking about point-slope form and then jump back to slope-intercept form? Why would we do that? Well, how closely are all these things related? Really closely, right? We can hop between any of them at any time. Yeah? All right. That's it. We're done with the lesson. Now, stop for a second. Point-slope form uses x's and y's, correct? But how else could we read that? Could we read it as y minus output equals mx minus input? Output and input, we know those. Could I also read it as dependent variable minus dependent variable equals m IV minus IV, IV1, right? Because if I'm not using x and y, if I'm doing something in real life, I'm not going to use x and y, am I? Like if I'm doing one of those taxi cab questions, right? What would this be? Time. And this would be cost, right? So this would be cost minus your initial cost equals your slope, and then your time minus your initial time. Everybody understand what I'm saying? It doesn't have to be x and y if your graph isn't x and y, right? Remember that question that we did with altitude and temperature, right? Would you use x and y? No, you'd use t and m, right? Everybody cool? You can if you want, it's recorded. But you already know that. You know that x's are independent variables, whatever they are. And you know that y's are dependent variables, whatever they are. Everybody good? All right. 15 minutes, like I said, to work either on 204 and 5 or on today's work. 204, 205, please. There are the first two questions. You get 2 marks for the work. You get 1 mark for the graph. Now, please notice I've put 2 different graphs up, yes? Because you had a fraction here, I changed the scale to make the red line. So I went, every square was worth a third. So I went up 4/3. Now, if you're uncomfortable doing that, I also graphed the blue line where every square was worth 1. So I went a little bit past 1 to 4/3. Okay? I don't care which one you use. It's totally up to you. Anybody need any more explanation as to how number 1 worked? Going once. Going twice. Going thrice. It's out of 3. You isolated y to get it into slope-intercept form. So you did algebra. You brought the 2x over, which made it negative. You brought the 4 over, which made it positive. Then you divided everything by 3 to get rid of the 3 with the y. If you can't do that, that's algebra. That's pre-me. Right? You got to sort that out. We only got 10 days left in class. I can't teach you 8 years worth of algebra. That's on you. Okay? All right. Number 2, same thing. I use my 2 intercepts. Where did the y go here? Well, y was 0, so I didn't have to care about it. Then I just do algebra. Again, I got a fraction, so I made each square worth a half on the red line. If you're uncomfortable changing the scale, I put my blue dot halfway between 1 and 2, which is 1.5. The other one was at -3 and I connected it. Again, I do not care which you do. But if you change the scale, you have to show me by at least giving me 1. When I see that, I know that that means 1 square is worth a half. It's out of 3. 2 for the work, 1 for the graph. Everybody good? Next question. Slope. I don't care how you did it. I, of course, showed both ways because some of you guys need to see both ways, even though they're exactly the same thing. As long as you decide which one. In the black ink, this was y2 and this was y1 in the black ink. In the black ink, y1, y2. In the red ink, it was the other way round. But we get to the same answer, and it is, of course, out of 2. Any questions about slope? Gouda. Find the line parallel. Parallel means it has the same slope. So if you put this in slope-intercept form, you get the slope. Every parallel line has that slope. So the answer was 5/3. Also for 2. Next question. Perpendicular lines means opposite reciprocal slope. So I found the first slope by doing slope-intercept form, and then I said to myself, I need the perpendicular slope, which is opposite and reciprocated. So I took negative 7 over 2, made it opposite, positive 7 over 2, then reciprocated it 2/7 for 2 marks, making that whole page out of 2, 4, 6, and 3 is 12. Any questions? All right, turn the page over. The easiest way to do this yesterday was doing a graph. But after today, isn't that an x and a y and a slope? So you could have used point slope form after I taught today's lesson. But you were supposed to do this last night. The whole point of this was you were supposed to do this, then I was going to go back. We were going to mark it with the graph. Then I was going to go back and show you how you could have done it after today with point slope form. But we reversed the order today.
-2 and -4. Because if you went down 2 and then right 3.
Down 2 to -4. Oh yeah, it should have been -2. Thank you. -2. Thank you. Everybody cool? Now, could you have gone up 4 and over 6 and told me that point? Yeah, but why would you? Right? Obviously, you would go 2 and 3, yeah? So most of you will have one of those 2 answers if you did this at all, out of 2. Everybody good? And lastly, when you sketch it, this is the only possible right angle, yes? So you check the 2 slopes, you find they are not negative reciprocals, so it is not a right angle triangle.
What if you did CB and AC instead of BC and DA?
Why would you do CB and AC? Check there. But even if you did that, you would find that's not a right angle, and if you did that, you would find none of them are right angles. So if none of them are right angles, it's not a right angle triangle.
So it doesn't matter what you check.
Tabi.
Yeah.
Well, unless you check, if you didn't sketch it, you'd have to check all 3. When you sketch it, the only one it could possibly be is here. These 2 are obviously not right angles. So this is the only one you should have checked. If you were only going to check one, you got to check that one. If you didn't draw it, you got to check all 3. So, it's going to be out of 2, but if you checked one of the wrong ones without graphing it, then I can only give you 1 out of 2. Do you understand why? Because if I put this on a real graph, even without sketching, you could plainly see that this is the only possibility. Yes? Tabi. How did I graph 1 and 2? Like up here where I said going once, going twice, going thrice? Oh, all right. Well, again, I don't really know where you're having an error or having trouble with graphing them. I'm going to make it really big so it will be easier, I hope. Can you put it into slope-intercept form? Are you cool to get to here? Okay, so this is the y-intercept, yes? It's a fraction. So the equation is that, right? So I got to go to 4/3. It's a fraction, so that's a pain. So I'm going to go 1, 2, 3, and I'm going to say that's 1. So how big is 1 square now? 1/3. I need to go to 4/3, don't I? So 1, 2, 3, 4/3. And my slope is negative 2/3. Down 1, 2, right 1, 2, 3. Down 1, 2, right 1, 2, 3. Done. Now if you don't want to change the scale, then 4/3 is a little bit past 1, right? And down 1, 2, then out 1, 2, 3. Right there. But I don't know why you wouldn't change the scale. And then the second one's the exact same way. Second one, my two intercepts were -3 and 1.5, right? 1.5 is a pain because it's a fraction. So I do 1. What does that make this? 0.5. I need to be up at 1.5. 1.5. And then -3. There's -1. There's -2. There's -3. Because each square is worth a half. Then I do that. Or, if I don't want to change the scale, 1.5 and 1, 2, 3. Gouda, grapes, and it's 10:30, exactly when I said it would be. It's almost like I've done this before.